Sharding data across geographies in distributed systems with OS and SageMaker. Definition. Sharding is the practice of partitioning data across multiple geographic regions or shards in a distributed system to improve data locality, reduce latency, and enhance performance for large language models (LLM) and retrieval augmented generation (RAG) projects. Leveraging AWS, Amazon Web Services, and SageMaker. Key components: AWS Services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale. Integrated with AWS sharding strategies for global data distribution. DynamoDB, fully managed NoSQL database service with built-in sharding capabilities for distributing data across multiple geographic regions. Global Accelerator, AWS service that improves global application availability and performance by routing traffic to the closest AWS edge location. Route 53, AWS Domain Name System DNS service for routing end users to AWS applications. Leveraging global data distribution strategies. S3, Object Storage Service for storing and accessing data across geographically distributed regions, enhancing data availability and access speed. Sharding techniques. Data partitioning divides data into smaller subsets or partitions, shards distributed across geographies or regions to improve data access and reduce latency. Geographic replication replicates data across multiple geographic locations to ensure data locality, enhance fault tolerance, and improve disaster recovery. Global load balancing distributes incoming traffic across multiple geographic regions to optimize resource usage and improve application performance globally. Consistency models defines consistency levels, e.g., eventual consistency, strong consistency to manage data synchronization and replication across distributed shards. Benefits: latency reduction reduces data access latency by locating data closer to end users through geographic data distribution and sharding strategies. Scalability scales data storage and access capabilities across geographies to accommodate growing data volumes and user demands in distributed environments. High availability enhances fault tolerance and availability by replicating data across multiple geographic locations, ensuring data access continuity and resilience. Disaster recovery improves data recovery capabilities and business continuity by maintaining redundant data copies across geographically distributed shards. Global application performance optimizes application performance globally by distributing data and workload across geographies, improving user experience. Tools and technologies. AWS DynamoDB, fully managed NoSQL database service with built-in sharding capabilities for distributing data across multiple geographic regions. AWS Global Accelerator, service for improving global application availability and performance by routing traffic to the closest AWS edge location. AWS S3, Object Storage Service with built-in capabilities for storing and accessing data across geographically distributed regions, supporting global data distribution. AWS Route 53, AWS Domain Name System DNS service for routing end users to AWS applications. Leveraging global data distribution strategies. CloudFormation, infrastructure as code (IaaC) tool for provisioning and managing AWS resources, ensuring consistency in sharding configurations. Challenges: data consistency. Managing data consistency and synchronization across geographically distributed shards to ensure data integrity and reliability. Network latency. minimizing network latency and optimizing data transfer speeds between geographically distributed shards in global data distribution. Cost management, monitoring and optimizing costs associated with global data distribution and sharding strategies to balance performance improvements with operational expenses. Compliance and regulations, ensuring compliance with data protection regulations and addressing legal requirements when storing and distributing data across geographies. Performance tuning, fine-tuning sharding configurations and consistency models to optimize data access speed and resource utilization in distributed deployments.